Hello students, let us see the next part of the chapter. The Earth's gravitational force. Now what is meant by Earth's gravitational force? We know that Earth attracts every object towards itself, and the force with which it attracts the object towards itself is nothing but the Earth's gravitational force, or it is also called as the gravity. Now this gravitational force of Earth is always directed towards the center of the Earth, because the center of the mass of the Earth is nothing but the center of the Earth, and so due to that, if any object is thrown upwards, that object always falls vertically downwards. That means it is always directed towards the center of the Earth. Now let us consider the example of Earth and apple. Whenever an apple is thrown, it falls down. That means Earth gravitational force attracts the apple towards itself. Then let us see whether apple also attracts the Earth, or apple also exerts a force on the Earth. Yes, but as the mass, let us consider the mass of Earth and apple. If you find the difference between Earth mass and apple's mass of the apple is negligible, and so due to that, though force of apple has a force on the Earth, then also the force will be very negligible, as the mass of the apple is very negligible and mass of the Earth is large, quite large. So larger the mass, large will be the gravitational force of attraction. Let us consider Earth and Moon. Now Earth attracts Moon towards itself, or Earth also exerts a gravitational force on the Moon. In the same way, Moon also exerts some amount of gravitational force on the Earth, and so due to that, we experience low tides and high tides in the ocean or in the sea. Correct? But the Moon does not fall on the Earth. What is the reason behind it? Due to the velocity of the Moon, as Moon also revolves around the Earth with one velocity, and so due to that velocity, Moon does not fall on the Earth. This is the big reason behind it. Same reason is behind the satellites. The artificial satellites which are sent into the space, they do not fall on the, or the weather satellites which are sent above certain kilometers on the surface of, they revolve around the Earth. They do not fall on the Earth. The reason behind it is also the same, that is, they have a certain velocity, and so due to that velocity, they do not fall on the surface of the Earth. Same thing I have explained here. Satellites along their orbits do also have some velocity, and so they do not fall on the surface of the Earth. Now let us see Earth's gravitational acceleration. Gravitational force which results in acceleration is called as Earth's gravitational acceleration. Now how to calculate this value of G? Let us consider the first formula. Force is equal to G capital M into M upon R square, where G is the gravitational constant, M is the mass of the Earth, small m is mass of the planet or the object, R square is the distance between the two objects. Then other formula for force is mass into gravity, that is mg. Now let us compare these two equations. What we get? Gmm upon R square is equal to mg. Now this small g will get, small m will get cancelled, and what will get? G is equal to capital G into m upon R square. That means the gravitational force does not depend on small m. That means it does not depend on the mass of the object. It depends upon mass of the Earth and the distance between the object and the Earth. So this formula is very important. So value of G, whenever you will substitute gravitational constant, mass of the Earth and the radius of the Earth, you will get G is equal to 9.77 meter per second square. This is the standard value of G. Acceleration due to gravity depends only on mass of the Earth and radius, that is capital R of the Earth, not on mass of the object. This is the important point to be noted. That is, it does not depend on the mass of the object. Now let us consider the value of g. How to calculate the value of g, or whether the value of g remains same everywhere on the earth. It does not remain same. Why? Because our earth is not an exact spherical shape. It is not an exact sphere, but it is bulgy at the equator and it is little bit flattened at the poles. So due to that, if we'll see the value of g on the surface of the earth, it is value of g is highest at the poles, because if you consider the center of the earth as here, then this distance decreases and this distance increases. Suppose an object is here at the poles, then distance from the poles to the center of the equator decreases, and distance from this surface to the center of the earth increases. And so due to that, value of g is highest at the poles, that is 9.832. For calculation purpose, we consider it as 9.8, and value of g at the equator is 9.78 meter per second square. Then let us consider the other point as height, change due to height. Now as height increases, value of g decreases. Suppose you will consider an object at a height above the surface of the earth. Now as the height goes on increasing, then value of g decreases. What is the reason behind it? Because the distance from the center of the earth to the object, this distance is r square and it is to the denominator. So if this value goes on decreasing or increasing, then value of g will decrease, because they are inversely proportional to each other. So for more examples, see the table number 1.7 from your textbook. You will get the idea of the whenever the height increases, the value of g goes on decreasing. Now let us consider the third point as depth. Whenever as you go below the surface of the earth, whether the value of g increases or decreases, it instead of increasing, it again decreases. Now what is the reason behind it? The value of m, that is mass of the earth, decreases as a part of earth which contributes towards gravitational force felt by the object also decreases, and capital R also decreases. Therefore, g also decreases. Instead of increasing, it decreases.